Now I want to do a couple more problems out of section 2.7. And these are where we start now with rational expressions. So now it's like we're going to have a fraction. And we go about it pretty much the same way with maybe one little twist at the end that sometimes comes into play. So let's look at this problem. X minus 2 over x squared minus 3x minus 10, all that greater than 0. Well, the first step is to make sure one side is 0, and I already have that here. Now I need to factor, and it looks like the denominator is going to factor. So now I'm going to have, looks like it's x minus 5 x plus 2. And all of that is greater than 0. So now I need to find my zeros. So I look at all the factors and see what value of x would cause each of the factors to be 0. So I look in the numerator, x minus 2, the value of 2 would cause that to be 0. I look in the denominator, and a value of x equal to 5 would cause that to be 0. And for the second one, it's negative 2. Now I'm going to do this now whenever I find my zeros from factors in the denominator. I'm just going to put a little square around them because in certain problems it becomes important at the end to know whether the zeros came from the denominator or the numerator. So now we'll do our graph. So I'm looking at values of x of 2 for one of my boundaries, 5, and once again I'm going to put the square around the 5 since that 0 came from the denominator, and then negative 2, and I'll put that box around this. So now I'm going to have, looks like 4 regions. So I do my normal sign chart. Region, test point. Now I list my 3 factors. X minus 2, x minus 5, x plus 2, and the overall. And now I need to go ahead. Here's my 4 regions. Choose a test point for each region. For region 1, I'll choose minus 3. For region 2, I'll choose 0. For region 3, I'll choose 3. For region 4, I'll choose 6. So let's do our sign chart. For region 1, minus 3, negative, negative, negative. You multiply 3 negatives, you still get a negative. Region 1 is negative. Region 2 for 0, negative, negative, positive. When you multiply these out, you get a positive. So region 2 is positive. Region 3, test point of 3, positive, negative, positive. So region 3 is negative. And then region 4, test value of 6. It's going to be positive, positive, positive. So region 4 is positive. Now if I go back and look at the original problem, it's asking me when is this thing going to be greater than 0, which means when is it going to be positive? Looks like it's going to be positive in region 2 and region 4. So I simply say my solution is the interval from negative 2 to 2 union with the interval from 5 to infinity. And that should be your solution. Now in this case, I never really had to use the fact that the 5 and the minus 2 came from the denominator. However, I'm going to do one more problem, and you're going to see at the end that it does become important knowing where the zeros came from. So let's do this one last problem. It's going to be x plus 5 over x squared minus 7x plus 12, all that less than or equal to 0. So here we go. One side is already 0, so I need to factor. And I believe the denominator is going to factor. And it factors into, I believe, x minus 4 times x minus 3. So now my zeros, from the numerator, minus 5, from the denominator 4, I'll put my box around the 4, and 3 with the box around the 3. So now with the zeros, I can create my graph. So I've got 4, well first 3, I'll put the box around it, and then 4, and then minus 5. Looks like I have 4 regions, region 1, region 2, region 3, and region 4. Now I need to go ahead and just create my sign chart. So here's region, test point, and then my factors, x plus 5, x minus 4, x minus 3, and then overall. I have 4 regions. Now I can choose a test point. For region 1, I'll choose minus 6. For region 2, I'll choose 0. Region 3 is sort of tricky. Has to be between 3 and 4, and of course you cannot choose one of the boundaries. So I'll have to choose like 3.5, or some of you might like to pick a 3.5. It's the same thing. Then region 4, I'll choose 5. Now for our sign chart. For region 1, negative 6, negative, 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 overall negative. Region 1 is negative. Region 2, test point is 0, positive, negative, negative, you multiply them together. Region 2 is positive. Region 3 is positive, negative, positive. Overall, region 3 is negative. And then region 4, with a test point of 5, positive, positive, positive. Overall, it's positive. So now I go back and I look, and I'm trying to figure out when this thing is less than or equal to 0. So in a sense, I'm trying to figure out where is it negative or equal to 0. Well, the negative regions are region 1 and region 3. So let me write down what would seem to be a normal or natural solution. And then we're going to talk about it. So you would think, since we're including the zeros, region 1, I would say negative infinity to minus 5 with a bracket. And I'm going to union it with region 3, which goes up in a bracket 3 to 4 with a bracket. So this is what you would think at first glance, since it's less than or equal to 0. So it's like we're including the boundary points. But you know what? Let's think about this. Minus 5 is a boundary point, and that boundary point came from a factor in the numerator. If x is minus 5, then yes, indeed, this whole thing equals 0, because you have a 0 in the numerator. However, if I go look at my other zeros, if I look at 3 and 4, what if x is 3? What happens? Is this whole thing 0? No, it's not. The 3, if I look at the denominator, if I stick the 3 in the second parenthesis, that will cause the denominator to be 0, and we can't have that. We can't have the denominator of a fraction equal 0. So even though I'm calling these points my zeros, 3 and 4, actually both of them are not true zeros. And that's because they're the zeros that we got from the denominator. And that's why I put the boxes around them. If I'm looking for less than or equal to 0, I cannot include the boundary points where the zeros came from the denominator. Because these boundary points, the expression does not really equal 0. It would be undefined if I chose those points. So instead of this, the first interval is fine, -5 with the bracket, but interval 3, I still have to put parentheses because I cannot actually include x equal to 3 and x equal to 4. Because those do not equal 0, they're undefined. So therefore, the interval is going to be anything between 3 and 4. Okay, so those are 2 examples of solving these rational expressions in an inequality.